So today we're going to learn the cosine double angle formula, and we have a triangle here which we're going to use, which is x, y, and z. And we know it's a right triangle because 5 squared plus 12 squared equals 13 squared. And the question they want us to figure out is what is cosine of 2 times angle x, y, and z. So let's start by listing the cosine of angle x, y, and z, which is 5 over 13, and sine of angle x, y, and z is 12 over 13. So we have to first list the trig identity, which will aid us in solving this question. The cosine double angle identity is cosine of 2 times an angle equals cosine of that angle squared minus sine of that angle squared. Now we have to apply the formula to our question, and so which is cosine of 2 times angle x, y, and z equals cosine of angle x, y, and z squared minus sine of angle x, y, and z squared. So this is our formula this is our equation that we have to solve in order to solve the question. So we know that cosine of angle x, y, and z squared is 5 over 13, and we bring the square down. And we know sine squared of x, y, and z is 12 over 13, and we bring the squared down too. So we minus this by that. So 5 squared, we distribute the squared to both 5 and 13. So 5 squared is 25, and 13 squared is 169. And then we do the same here where we distribute the squared to both 12 and 13. So 12 squared is 144, while 13 squared is 169 again. Now we move on to what we have. We have 25 over 169 minus 144 over 169. Now if we simplify this, we get negative 119 over 169. So we have a negative value, negative 119 over 169, and to understand this, we have to look at the unit circle, which is basically an extension of the SOHCAHTOA definitions. So our angle x, y, and z is in the first quadrant, which this is the angle, and we see that it's in the first quadrant of the unit circle, and the x coordinate is positive. It's positive. But if you double this angle, we are in the second quadrant now, if you double this angle. And the x coordinate is now on the negative line. Therefore, we have the negative value.